Okay, not the interpersonal skill or communication skill. Of course, the way we nurture talent, that is definitely part of that. 70% prominence goes into technical skilling. Very important, 20% in the management, time management, quality management, data management, and the 10% is interpersonal. How you communicate, how you explain a design to somebody else, how to work between various functions. So in this slide we are talking about technical functions, level 4, level 5, level 6, level 7. So we can assume that, okay, engineering, 4 years of engineering in India, that is well, first year engineering you can acquire this. During second year you can acquire capability of this. So now if most of you in front of me are engineering graduates, so I can say that each of you can acquire all these level 4, 5, 6, 7 together, because you don't go to a college, or maybe you're about to get into a job. So you can acquire these skills in one go. Maybe you spend 4 to 5 months. 4 months we say, but maybe even if you chew it, design is a tasty subject, so you can take as much time as you need, and in 6 months time you can acquire all these skill sets. So let's imagine let's analyze what it is. Say level 4, you can do prototyping, 3D printing and all comes in that. Test engineering, when you have a product you can do the testing. So I in the next minutes I will show interesting slides and or videos which will explain these things to you. Level 6, a little higher, where computer aided engineering, that is analysis. You do crash simulation, you do fluid flow, that is aerodynamic simulation, all these kind of. And when you are the highest skill level, level 7, is when you have all these put together, entire product development, from drawing, design, analysis, prototyping, testing, everything all together. So this is where our tie-up with ASDC is helping all like you across India. We get you the skills, and we can certify. ASDC, that is Automotive Skill Development Council, goes by this QP qualification pack. So this certification from from NSDC is valid globally for any industry. It need not be just for automotive industry, aerospace, defense, or consumer goods, transportation, any engineering discipline across the world. This kind of certification helps. Okay, so these are the host of companies which we have associated in the past 10 years, so to say. Around 10,000 people in our database. We know where they are working for various companies like this. Some of popular companies I have listed here. So Tata, Mahindra, ARA, Pune, Design Tech, Infosys Engineering, BHEL, TVS Osur. Interestingly, some are abroad. Wissenbaum is a German company. Senshin is a Japanese company. So these are companies where people have just joined with this kind of skill certification in the past years. And there are companies like UST Global or ARA, Tata Elxsi, which they have used our tailor-made programs to bridge the gap. They recruit from campus, and then we give the training in these domains, and they absorb these people. So this is the setting the context. Now to talk about how to develop career in automotive R&D or general any product development field, I can spend in the next half an hour, I suppose. Any questions here? I will take a few seconds break here. Anybody, any question from on what you have heard so far, or what you want to listen?
Means for a mechanical engineer, which are the important softwares that we have to upskill that have some few?
Sure. Later in the discussion, I'm coming to these things. I'll answer that, but I can demonstrate that also. But since you have asked, let me just tell you quickly that um, uh, basically CAD. Initially I showed you some images here. Okay, let me go back for a second here. So CAD is a very important tool for any mechanical engineer. It is like these days even 12th standard students work on CAD. There are various CAD software. When I say CAD, computer aided design. Okay, so it can be AutoCAD, the good old AutoCAD, or to the latest SolidWorks or CATIA. Nowadays there are free open source software like Onshape or FreeCAD. There are several CAD softwares. I don't want to name companies under that, but take it from me, CAD software. Okay, I have just written here. Then comes the CAE software. That is where popular softwares like ANSYS, HyperWorks, or Nastran. There are these kind of softwares do the analysis. How much is the strength? How much is the vibration resistance? How much is the endurance? All the so this is designing. This is analysis, and then there are 3D printing software like Cura and all. Even testing has got software, like LabVIEW and all. But these are the basic CAD and CA is very essential since you asked for the priority. I hope I answered the question. Okay, now let's watch some videos before we move ahead. Mohan, is the audio, is it audible?
Well, we cannot hear any audio in that.
All right. Yeah, it's only a background music, so it doesn't matter. Okay, so maybe I can just talk through.
Yeah.
I'll yeah, as I play. These are the two things I can repeat: electric vehicle and alternate material. We all hear about autonomous car. Electric vehicle is everywhere. Okay, now the next generation autonomous cars, self-driving cars. So how to design not only the automobile but even the roads, everything. Recently one of my student trainees designed a what do you call a post, a lamp post kind of, which hosts a camera to guide these vehicles. So even that is design. So a lot of work is happening in electric vehicle, autonomous cars, and alternate material. You would have seen many videos, like low cost design, sustainable material, low carbon. And so we are all preparing a clean, safe, quiet world. Okay, this is the theme. Clean is a zero emission vehicle, electric vehicle is something like that. Or even if we move from our Euro 6 to Euro 7, the next stage, it's a clean vehicle, clean petrol, clean diesel, hydrogen vehicle. So it's a lot of engineering happening. Crash, so that is the safety aspect, like even Tata Nexon, Mahindra XUV 700, all these Indian vehicles are Euro NCAP 5-star rated. If you see the newspaper, many of you will be sharing these things over WhatsApp or Instagram. So, and then quiet vehicle, like no noisy, even petrol engine or diesel engine wouldn't be making noise. And inside the cabin you don't listen to outside vibration or engine vibration. So it's a lot of engineering. Whatever you have learned in your curriculum, in diploma or degree or post graduation, when you apply those things, that's called a product engineering. All right, so this is a video which takes you through all these elements. Now this is one big theme. Your generation, the next generation, you have to be very optimal design. Earlier it used to be very heavy designs. Nowadays there shouldn't be any wastage of material, no emission hazard. So it should be optimal design, local. We all hear, right? Atmanirbharta, the self-reliance, the theme of today. local engineering. We used to import our laptops, HP or Dell or Toshiba, everything from abroad. Now, what if you develop a laptop made in India, designed in India? So, for instance, UST Global's Coconux is one company in Trivandrum. They engineer their products. They design laptops and sell in India. So it can go from local to global. And frugal, the word frugal is very, 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 what do you call, very low cost or right cost. I wouldn't say minimum or cheap. It's not cheap. It's the minimum cost for the maximum gain. So these things, India is well known for frugal engineering. That's where we do all the analysis and all to make frugal products. Again, the next generation is very, very serious about green and lean. Sustainability is very big. Only those material which is safe for Mother Nature should be used in designing an automobile or an aerospace or even a furniture. When you design, it shouldn't have any hazardous material. So this is something you learn to do practically. How to how to choose material, how to design very in a lean way and all. All right, so let me with this video, let me get into another presentation. If you are with me, shall we?
Yes, sir.
All right, good to hear. So you all asked about some softwares. Okay, including that, I can show in the next few slides. Let me take another 20 minutes of your time to take you in a quick way how product design and development is used. Now, career. Let me talk about the career first. Many engineering fields are there. You can. The most popular is the manufacturing, right? You make things, and then you have logistics. These days, Swiggy and Amazon and other things have made the word logistics very, very popular. Even engineering graduates go into that field. It's a field. Sales and service. We all know when we buy a product, we go from the showroom, we take it to the service garage or service center for repair and all, and then the spare parts engineering. So these are all the popular ones in the product life cycle. But one step before that, who will design the product? Before you manufacture, you need a drawing, right? It's just like a cooking recipe and the dish. Manufacturing is the dish in hand, okay, on your plate. But where is the recipe? So that is the drawing, the engineering drawing, which we all have tried and tested, even whether it is diploma or degree or post graduation. In our first year, we have done engineering drawing. So it is that drawing, the top view, front view, side view, the same good old thing. That is the what do you call, the most sacred document for manufacturing. So who will do the drawing? A design engineer. Okay, he or she will do the modeling, analysis, prototyping, testing, everything, and then the final drawing in the form of design, final design in the form of an engineering drawing is released. So that is it starts with a simple sketch and ends with a drawing. And in between comes all these steps like simulation. I spoke a couple of times what is simulation, crash analysis, aerodynamic analysis. So now this you would have seen. It is not animation. It is all behavior, Newtonian physics. Following engineering simulation is following Newtonian physics, right? It's all mathematical. So a scientific animation, you can call it as a simulation. So this is where CAE tools, computer-aided engineering tools like ANSYS or HyperWorks are used. So thus, virtual product development is everything. Everything can be done in the software and that is computer-aided. So one of the participants asked the question, what kind of software should you know? I replied, at least CAD and CAE. Data, but there are many more, like a computer-aided industrial design is there. Okay, so I know some of the participants today are from the industrial engineering background, so they would have used softwares like Keyshot or Blender or even Rhino or Alias. Those kind of softwares will help you to do the initial sketching. then the CAD works. So there are much more planning software, computer for even project management. So the popular ones I have listed here. I have already answered that question. Now this is a sketch of how do you do the product development. So it is very easy to say you acquire skills and you become self-reliant. But I told you it's not as easy as I say or you feel. It's a 4 months of effort you need to take in doing these things practically. It is not learning any theory or any books or anything. It's all simply practicing what you have learned sometime, or still what you need to learn some more. So you design, say this is a simple device. You can see something like a desktop device, a stapler come a punch press. Okay, so or we can say it's a paper cutter and punch combination, not stapler, paper cutter and punch combination, a combo device. Now then some market intelligence is required, product styling with using the computer-aided industrial software. Then you come, you do a lot of the design validation, testing, product testing, and then advanced terms. Into the third month or fourth month, you get to know what is geometric dimensioning and tolerancing. So these are various things. Though none of these things is part of our engineering curriculum, but very much needed for a job in R&D. As I told, right, day one productivity. You acquire these skills and then you are readily deployable. You can start with a very good salary, say 25,000 or 30,000, even in a small company. So like big companies like Tata or Mahindra will pay you much more, and even ISRO or DRDO, like a government sector, even they pay much more. And there, as we speak, there are open jobs with ISRO. Some of you would have applied for that, I know. It's January, February, the hiring is happening for R&D engineers. So everywhere they need these kind of skills. This is the skill measurement. At enjoy, as you finish a module in 2 weeks time, you know where you stand, you know what kind of skills you have. Level 6, for example, what is shown here, you should know what is failure mode effect analysis. You are already trained on ergonomics, how to design for ergonomics, design tools, the softwares you are good to handle. You have enough 200 hours of practice already in the first 2 weeks for to become a product design engineer. So this is the ASDC's definition of skill framework. And look at now, the step beyond ASDC is the automotive industry, right? So now I show these examples. North India with a few automotive companies. Western India has many more with General Motors, Daimler, and all. Maybe South India, Chennai is called the capital, right? Auto capital now. Earlier it used to be Pune. Nowadays Chennai is the Detroit of India. So where a lot more companies, Daimler, Volvo, Mitsubishi, Ashok Leyland, Mahindra, BMW, Ford, Toyota, a lot more companies are there, and all their suppliers, Wheels India, MRF, what do you call it? Brakes India. Hundreds and thousands of companies look for people like you. And apart from that, R&D centers in India, like NATRIP is a national testing authority. They are in New Delhi, Indore, Chennai, and Haridwar. So they are also recruit people for the last 4-5 years. As I told you, pedestrian safety and automotive safety, both are important. So ever since 2017, crash regulations are enforced in India. A lot more engineers are required for safety, doing design for safety, crash analysis, stuff like that, airbag simulation. Lots and lots of engineers are required. This is the latest Euro 6 parallel to the electric vehicle revolution in 2020 and 21. This is happening where petrol engines are made more and more emission compliant. So from Bharat stage 3 to Bharat stage 4, and then suddenly to Bharat stage 6, skipping level 5. So it's a lot of engineering which has gone into design of the engine, the catalytic converter, even the silencer tailpipe. construction is a big boom. So all these companies you would have seen recruiting big. L&T Engineering, Komatsu, Tata Hitachi, even Hyundai has got the excavator division, and our government sector BEML, Bharat Earth Movers Limited. They also recruit people like you in Mysore. So even to design such heavy vehicles, extraordinarily large vehicles, the fundamentally same. How to design a frame. The same frame is there in the automotive chassis, or even a bicycle frame. It carries, like maybe only two tires, two wheels in a bicycle, whereas it could be 10 wheels in a special vehicle, or 6 wheels in a multi-axle Volvo bus. So wherever it's a 2 wheels or 10 wheels, you need a frame to host, and that is how you do the design analysis, just like how you have done the calculations in your third semester of engineering mechanics calculation. So I again named some few companies here, a lot of jobs around, and this is how you practice. Some images, now you get an idea. When I keep telling what is design, this is it. It is not just drawing something or doing a CAD model. It is all the calculations behind that. What kind of material is required, where to punch the holes, what is the diameter of the hole, what should be the fillet of the hole, what is the tolerance between this. So it's a lot of I am not going to add to the boredom by talking about such jargons, but just believe me, this is very exciting once you start doing. Listening may not be that exciting, I swear, but then doing is very, very exciting. And if you do the testing in college labs, you would have done the testing, right? Somebody's design, you go there and validate, you break it, you bend it, you test it, you measure the flow and everything. So likewise, if you can measure the stress and strain in the lab or on the computer, this is computer aided engineering, right? You measure, this is the hot spot where the crack can occur at this point. So this is analysis. So when you need to know the design, then only you can do the analysis of the design and do the testing of the design, or even developing the prototype of that. So essential thing is the engineering design. Several case studies you do. I'm skipping a few things in the time is precious for us. So you are all welcome to post questions later. But then these are the kind of simple designs you will handle initially, as if how to design a simple ladder and find the bending in the third step or the fifth step, where the maximum bending will happen. So this is where you use the software. You learn the software, how to draw a line, how to draw a circle, how to extrude, all the CAD operations you will learn. At the same time, you do all the finite element analysis. You learn how to do the stress analysis, vibration analysis, measuring the factor of safety, everything on the software. Now, should I take a pause and take some questions? A few more slides in this line. Any questions here?
Friends, you can type your questions in the chat window also, or you can unmute yourself and ask.
Yeah. And if they type, Mohan or Aravind, please read it out to me so that I can answer this.
Hello, Gobi sir.
Yeah, please go ahead.
Sir, when we think about the engineering analysis, of course, we'll be applying all the concepts that we have learned in the engineering. Okay, maybe strength of materials or engineering mechanics, all those concepts.
Oh yeah.
But to correlate the output that we get from the analysis, or to validate that whole design, is a basic knowledge about the strength of materials or all this theoretical concept is enough, or should we have a little more in-depth knowledge about the various criterias and failure modes and criterias and all these things? How far the theoretical base is important?
Yeah, good question. It prompts me to deep dive a little bit. You asked the question for validation of the design. yes, then you need to know a little more advanced. But if it is a simple design verification, so that's the difference. If you say there like a step is there, if you want to know whether the step will buckle, or bend, if 100 kilogram, a man with 100 kilogram is standing on that. So it's a simple design verification where the basics are enough. What you learned in the engineering curriculum is enough. But if you imagine this is a product, okay, the rail as a product, you want to validate it. A validation means it is not only for the design but also for the usage, the manufacturing aspect, whether it is corrosive, whether it will, the holes will rust, or sorry, when you tighten, whether it will sink into the material, will be eaten out, or so. That becomes the total validation, where you need to know the advanced thing also. What kind of material, what heat treatment, what Brinell hardness is required. So you need to understand all the elements of material manufacturing and the geometry, then only you can do the validation. Same with a product like a connecting rod. It is not easy to do the validation. Because this is something, it withstands several 2000 3000 degrees of temperature, degrees Celsius, high RPM. It rotates at a high RPM. The peak gas force is very high. So then you need to understand all the nuances, the geometric dimensioning and tolerancing, the lubrication, all the detailed element. So that is part of your skill acquisition. So that you finally you decide to become a validation engineer, a test engineer. Most welcome. You need not, once you acquire all the design skills, you need not become a designer only. You can be an analyst, or a prototype engineer, or a test engineer. So that, I think that answers your question. You need to have advanced skills to become a validation engineer.
Okay, sir. Thank you.
Welcome. All right. So moving on. So design that way caters to anybody's need. Okay. So it can be a design of a building. It can be a small building or a very luxurious villa kind of. Likewise, an automobile, even Tata Nano will serve the purpose. The need is to transport, whereas a Porsche 911 or a Lamborghini also will serve the need for transportation at a much higher, utility. High speed, high performance, acceleration, braking, everything will be exaggerated for a Lamborghini, so to say. But for the executing the need, things start with the drawing. I told you, right? Everything starts from the drawing and then with the drawing. We know, even if you approach a civil engineer, you want to redesign your house, or build a new home, then you may make a drawing. This is where I need the master bedroom, I need a hall room here, a study room, kitchen should be there. You can also make a drawing, but then finally the contractor is going to make or build it as per the final engineering drawing by a civil engineer, a certified civil engineer. So that's why a concept drawing anybody can make, but the final production drawing only the skilled people can release. Modeling, the CAD, using CAD. So you would have seen CAD walkthroughs for civil engineering. People use the CAD software like AutoCAD or so to do the building. For automobile, nowadays AutoCAD is not at all sufficient. SolidWorks or CATIA or Onshape like software is required to do the CAD modeling. It could be a motor or a car or anything. The 3D modeling is done that way. Analysis performed with the easiest software is Altair HyperWorks. You can do the meshing, analysis, post-processing, everything, do all the analysis within that. Same thing with the ANSYS, Nastran, and such kind of softwares as the CAE software, where you are verifying your design. So if you are relying on the software, like the participant asked whether you need a deep understanding, may not be. The software will do the calculation, everything. Even if you don't know the theory behind, the software will predict. But if you want to become a validation engineer, you yourself need to know all that the computer, the CA software knows. And here comes the final design. Say now this is resembling our latest Thar, right? Mahindra Thar. It could be a Jeep Cherokee, the Wrangler, Jeep Wrangler, the American design. But now, initially under license from Chrysler, and now Mahindra independently is designing Mahindra Thar, right? It's a very, very beautiful vehicle. But whether it's such a product or even a simple plastic bottle, a Bisleri bottle, a mineral water bottle, both will have engineering behind. This car may be undergoing crash analysis. The mineral water bottle may be undergoing crush analysis. Okay, but both the products need to undergo all these analysis. So these are some engineering aspect. I won't take more than a minute here. It's as part of the design. I told you, right? It's a game. Designing is a game. You have to play all the parts. Then problem solving, essentially ergonomics, how it suits the human being. Cost is a very, very important aspect. If you design a Lamborghini, you don't bother about the cost. But if you design a Tata Nano, yes, you have to limit everything to 1 lakh rupees, or now it is 2 lakh rupees. So then only it will have its intended purpose. Okay, a very cost-effective car. This is where it's a lot of skill is required. Designing for cost, designing for manufacturing, designing for assembly, like DFM, DFA, designing for quality, and designing for cost, DFC. So all these terms are very, like when you go for a job interview, you may get a question like that. So suddenly you may not be able to answer such things. But if you go through this skilling process, then you do everything. You do design for aesthetics, and you do several case studies. Then you know how to take it from end to end, the product, and finally do the launch of the product. So it's the basic process from concept, design or idea drawing, to doing all the calculations with respect, correlating with your theory subjects. You do all simple calculation. If you apply X force here and it's a lever, what is the force amplification, magnification, whatever. So this is the design calculation, and then you refine all your design for manufacturability and user acceptance, and you finally comes up with the product development. So it's a combination of mechanical design and industrial design. Industrial design is those elements which pertain to look, feel, and other things. The color, look and feel of that. But the functionality is determined by the engineering design. I hope with these terminologies discussed in this forum, you have at least known what you know and what more you need to know. All right, so that's it towards the end of the technical part of it. Like how many of you have heard the word 3D printing, but now you can see how it looks like. It's these are the prototypes we have made. We don't call it manufactured. It's a one-time prototyping. Okay, using 3D printing. Whenever you design anything, it could be a tabletop. You can do a 3D printing. Yeah, it's a tabletop device, right? It may take 10 hours to do the printing. If you create a Word document, you may take, print it in just 30 seconds. Whereas you do a CAD model and give it to a 3D printer, it may take 10 hours to print a small 1 foot long device. So that's it. These are the technical aspects of it. Anything else you can ask, but meanwhile I can just play it as a video if some of you have not gone through each of these slides. Parallelly I can answer your questions also. Anybody wanting to ask can even write in the chat box.
Sir, good evening. This is Ashok from Chennai.
Hello, Ashok. How are you?
Yes, sir. Sir, fine. How are you?
Thank you. Very good. Go ahead.
Yes, sir. Sir, my question is this crash analysis and crush analysis, whether it can be done through ANSYS or some Nestron or any other software?
Of course, the many softwares are there. There are specialized softwares like LS Dyna.
Okay.
Now it is part of the ANSYS company. PAM Crash is yet another software. Altair has got radios. There are various softwares. These are all part of the CAE software, computer aided engineering. So
Yeah,
this
yeah,
is
fine,
a
fine.
real crash test, but you can do the crash analysis on your software. Any of these software can do that.
Okay, okay. Because as per my knowledge,
Yeah.
I have been a trainer, corporate trainer for ANSYS, CAD and AutoCAD.
Yep.
As per my knowledge, I have used this ANSYS for dynamic testing, that is
Right.
dynamic analysis.
Yep.
Not for this, sorry, no, not for this like crash and crash analysis like that.
That is
Because
true.
it needs.
Yeah, as a trainer, I know you would have acquired the skills years back. But whereas the company ANSYS has acquired this company LS Dyna only a couple of years back, 2 years back. So
Fine, fine.
no surprise that you have not used the crash module. Only earlier when I used this software LS Dyna 20 years back while I was working for Daimler in Germany. That's the first
Okay.
time I got to know. But then this software became so popular in all the Indian companies, Tata, Mahindra, even ISRO they have used it for the crash landing.
Yes.
Simulation of a crash landing in moon. All these things they have used LS Dyna. Now that is acquired by ANSYS, so now you can purchase it along with ANSYS. Whereas
Okay, fine.
Altair's HyperWorks, they also procured a company in France, radios, and now Altair
Yes.
has for last 15-20 years they can do the crash analysis within the HyperWorks. So those of you being part of this ASDC iNCAETEK training program, you can use the HyperWorks software to do the crash simulation.
Okay. So HyperMesh and HyperWorks are worked together right now, right?
Yeah. So HyperMesh
Yeah.
is the
For
meshing tool,
meshing, yes.
and
Meshing
then you
tool.
for analysis it's the HyperWorks suite, like the
Yes.
ANSYS suite. It is the HyperWorks suite. All
Yeah, yeah.
right.
I have
So
worked in several projects for basically for company training and also for students
great,
particular projects. So
great.
that's why I want to know about that.
Yeah, that's great. So that is software training. Yeah. Any other? But here we are talking about the engineering training.
എടാ കേക്ക്
Engineering.
പറയാനൊക്കെ അത് നീ
Okay,
ഒന്ന്
okay.
ഫോളോ അപ്പ് ചെയ്യണം. ഞാനത് അവർക്ക് അതിന് ഓൾറെഡി 10 വരെ ബൈജൂസും എടുത്തതാ.
Can you
ഹലോ
mute the line, please? Somebody is talking. Yeah.
Yeah, I think so.
All right. Now go ahead with the question.
Yeah, that was my question actually. Whether
Yeah.
ANSYS can, whether we can perform crash and test using
That
ANSYS.
that I answered.
Yeah,
Anybody else?
that is the upgraded version.
Yeah.
Thank you, sir.
Thank you, Mr. Ashok. Yeah.
Yeah.
Well, I'll take the last 5 minutes of mine before I answer further questions. This is the program Automotive Skill Development Council has partnered with iNCAETEK, ACE Design. So it is like Automotive Component Engineering Design. This is the passport to R&D jobs in any segment, because automotive component, if you learn to design, it's accepted world over that you can design anything. More complicated thing like defense or aerospace also possible, or less complicated like consumer goods or transportation, or even simple capital goods or the industrial machinery. So everywhere, so this is the base automotive component. That is why the global standard is that way. Same within in India, national skill qualification framework that is proposed by NSDC, National Skill Development Corporation, and that is where we are aligning with the level 4 5 6 7 4 5 6 7, the 4 levels. As you see here on the screen, there are, so when you get a certification, you get a certification number one from Altair, like part of this training, or from ICFOS, which we give. Additionally, you can go for a test and you can acquire skill certification from NSDC through ASDC. That is on these levels, level 4 5 or 6, level 4 5 6 or 7. Okay, this is the content of the course. So initially I told that the purpose is to close the skill gap and make each of you with the day one productivity in R&D. So for doing that, we have mapped all the requirements in industry. My 25 years of work experience is not the thing. It is several people, seniors have been in the committee, and then finally this is reviewed and how each level maps with the jobs. So that is how many companies like Mahindra R&D is already deploying, or ARA Pune or ISRO in Trivandrum. They recruit these kind of people who know how to do the crash analysis, how to do CAD modeling, how to do 3D printing, how to do testing and validation. So when you do projects as part of the course and later as internship, some of you have finished the course and now you are about to do the internship project, I know, then you do practical designs, and then that is how you polish your skills, and finally you can get the skills certification. Yeah, along with these technical skills, we need to have some sort of project management. I told you. So together, then you acquire the skill stars. So we have a talent platform where all your development is mapped. Like how much skill star you have in the drawing, modeling, and all the technical thing, plus your communication, your performance, participation, because that is when you become an engineer. The engineering talent, that is where we map it as talent dot. Okay, the more dots you have, we have a scale of 3 dots. Okay, like a 5-star rating for your technical skills and a 3 dot rating for your overall talent measurement. So that is all listed under the platform, which companies will see when you have your skill certification done, your resume, CV, or biodata is ready. That shall be seen by employers. So this is how the platform connects job seekers with the job providers. And that job providers, as I told you in the beginning, it need not be big industries, even suppliers, service industries, and even startup. Mind you, startups are growing very big. So if you have a small technical startup, they too need engineers. It may not be like a 125, 30 people like ISRO is hiring now in this month. It may be only 2 or 3 or even one engineer in a good startup where you do need to do end-to-end everything. In a big company, you are either a design engineer or a test engineer. Whereas in a small company, you have to do everything, all the elements of product development. That's where you develop yourself as a overall product development engineer. That is where the Atmanirbharta or self-reliance, you yourself can do the freelance projects. Imagine after acquiring skills, you do not want to leave a job, or you want to go for a government job where none of this engineering input is used, or you may do your MBA and get into a management job, but still in the evening time or free time or weekend or even in your vacation, if you have a computer and software in that, if you have these skills, then you can earn a lot. Earlier it was it used to be only the big employees, big company employees who used to do freelance work. Now everybody who is skilled in design has chosen to do freelance work, working independently. Just like civil engineers do freelance work with a building drawing, you mechanical designers can do consulting work in your free time, freelance work for product development. So this is the theme All India Council of Technical Education has introduced in the education. Instead of doing it all together at the end of your engineering in 4 months, do it over 4 years. So some of you students listening to me today can correlate that, okay, if you are in first year, you can do a little bit along with your studies. So you spend only 100 hours in 6 months time, another 100 hours in the next year. So by end of the 4th year, you get all 4 skill certification, just like your big brother has done that after engineering. Okay. All right. So that's it. I'll stop here and over to you. Anybody can post questions to me. I hope I am audible.
Yes, yes, quite audible.
Yeah. Any questions I missed, Mohan, in the chat box?
Well, no, I think mostly people have asked questions directly by unmuting
Directly. Yeah.
themselves, so nothing in the chat box as such.
Good, good. So thanking all of you for being a wonderful crowd. You participated, posted questions, and yeah, made the session live, I must say. So thank you, and big thanks to ASDC for hosting this event this evening. Some of you are working employees, so that's why we chose this time. Thank you, ASDC, for making this wonderful opportunity and helping them to decide what to do next in their to make a career. Thank you.
Thank you very much, Gopikrishnan sir. Thank you for providing the inputs. If there is nothing else, no questions as such, then I think we can end the session.
Thank you, Mohan. Thank you, team. So I think that's done. Thank you for the questions. Thank you, ASDC. Good luck to all. Bye.
Sir, excuse me, sir.
Yes, Ashok. Yeah.
Yes, sir. Sorry. By the closing time, I have interrupted you.
No problem. This is your
Sir,
session. Go ahead.
yes, sir. Yeah, I have a doubt because I have been an ASDC trainer in this same platform,
Yeah.
certified ASDC, but it was long years ago.
Yeah.
So whether I can able to write this exam and get a certification,
Easily.
because
Easily.
now I'm in 30.
Yeah, no problem. Age is no bar. I told you, this is a very, very unique opportunity. A, B, C, D. Ashok, if you have listened to me in the beginning, anybody can design. Okay, A, B,
Yeah.
C, D. Now, there is no age. Okay, whether you are age 30 or 40 or 50, because a design is
Uh-huh.
something where there is no retirement. You know, right? It
Yes,
is.
sir. But
Yeah.
my question is getting job. That is a big question, right? So at the age of 35, I can't seek a job in a different platform or even in
Mm,
different organization.
Well,
See, this is
let me tell you, even there are many juniors who are listening to you. See, age of 30, 35 is an age bar only in the government jobs. Okay, if you want to write a
oh,
PSC test, whereas in a private company, if you want to join ISRO, yes, it may matter. But if you want to join Ashok Leyland in Chennai, then age of 35 or 45 doesn't matter. Or
okay.
so that is possible. And now maybe at this point of time you can think of doing freelance work also apart from your trainer job. If you
Mm-hmm.
acquire additional skills, you can become a freelance worker. You can work for us in iNCAETEK, for example, in your free
Oh,
time.
fine.
So
That
at the end of it,
I'm glad to hear that.
yeah. So there are many companies like us who want people like you. So you can approach us or anybody else, or we can guide through our platform. We may do the matchmaking for Ashok Kumar's skills. We know some company is looking for a job, so we can do the matchmaking on the platform. So all you need is to enroll on the platform. You all of you friends can assess yourself for what is the skill you have currently. You may be a trainer, a good trainer, but you may be requiring some more skill in GD&T or DFM or FMEA and all. So you can validate where you stand and then
Okay.
fill the gap. If you need to a small certification program only, you can do that. That only, you need not do the entire module. So this is a
Okay.
very well structured course by ASDC, where you can choose as a whole or in small modules also. So that essentially you have to just fill the gap, skill gap, and then we will
Okay.
do the matchmaking for you or via on our platform.
Fine, sir. Thank you, sir. Thank you for your guidance, and we'll keep in touch with you.
Good luck, Ashok. Yeah, my team
Thank you.
will get back.
Okay.
Yeah, yeah, between Arvind and Mohan. Yeah, thank you. Uh,
Thank you. Thank you, sir. Thank you.
Good luck. Bye.
Okay, sir.
Yeah, thank you. If nobody else is having question, we will drop out here. Yeah, thank you.
Okay.
Have a nice,
Yeah.
thank you. Have a nice evening. Bye.
Bye.
Thanks a lot.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you. Bye.
Thank you, sir. Bye, sir.